to the Gulf Structural Insights podcast, where innovation meets expertise. Join us as we explore cutting-edge structural engineering solutions across the Gulf region, bringing you the knowledge and insights that help shape tomorrow's iconic structures.
All right, welcome back, everyone, to the deep dive. We're all about digging into those tricky bits of structural engineering that, let's face it, can cause some serious headaches.
Headaches, yeah, absolutely.
And today, we're taking aim at something that I'm sure resonates with every structural engineer out there, RFIs, those delightful requests for information.
Oh, yes, RFIs. Can't live with them,
Can't seem to avoid them, right?
Exactly, especially when we're wading into the murky waters of retrofitting existing steel or those urgent on-site fixes that seem to pop up out of nowhere.
It's like playing whack-a-mole with structural conundrums.
That's a good one, yeah. Feels like that sometimes.
Hey, no need to despair. We've got some really solid material lined up today that dives deep into some really practical approaches for managing RFIs related to structural connections. So we're talking, how do you handle those curveballs efficiently and effectively without pulling your hair out?
Right, and not just surviving those RFIs, but actually using them as a chance to showcase your expertise and add real value to the project.
Yeah.
And the sources we've got today, they really get into the nitty-gritty of how to do that. They offer some pretty tangible steps, and we'll unpack those and also talk about, what are the real-world advantages of applying these methods.
Exactly. And one thing that jumped out at me from these sources is they kind of pinpoint these two major categories where these RFIs tend to cluster. So first, we're going to dive into retrofitting, breathing new life into those older steel connections, bringing them up to code, maybe beefing things up for increased loads or seismic upgrades. It's almost like structural archaeology sometimes, isn't it?
It is, yeah. It's like uncovering the past.
Yeah, and then we're going to shift gears and tackle those on-site interference RFIs. The ones where there's a clash, something unexpected pops up during construction, and suddenly you need a solution and you need it fast.
Like yesterday.
Yeah, exactly.
Yeah.
Right. Those can be real nail biters.
Oh, absolutely. Those can be a scramble.
So let's jump right in, shall we? Let's start with those retrofitting RFIs. And from your experience, what are some of the biggest hurdles you encounter when you're dealing with retrofitting existing steel connections?
Oh, where to even begin? I think, as you alluded to earlier, really is like stepping back in time sometimes. Often you're dealing with, let's call it limited documentation, shall we? The original drawings might be, let's just say they leave something to be desired.
Right.
And then you've got materials that might not even be in production anymore. Those older steel grades, those historical profiles, things that you wouldn't even think about using in a new design today.
And then let's not forget about those quirky connection geometries, those details that were maybe common practice decades ago, but would make a modern engineer scratch their head.
Oh, yeah, absolutely. It's like a whole different world sometimes. And that's where things get really interesting because, you can't just rely on your trusty hand calculations anymore, especially when you're talking about seismic retrofits or significant increases in load demands.
Right. The sources we've been looking at, they really emphasize this point, that those traditional manual methods, they just don't cut it in these complex retrofitting scenarios. You really need a deeper understanding of how those older connections behave under these new stresses.
Yeah, and that's where, the sources really start to hint at a more sophisticated approach. And one tool that keeps popping up is IDEA StatiCa connection. Have you had any experience with that?
I have, yeah. And, one of the key things I've found is that it allows you to build a detailed, realistic model of that existing connection, which is huge. Because then you can analyze how it's actually going to behave under those proposed new conditions. It takes the guesswork out of the equation.
And that's really the core advantage, isn't it? You're not just relying on simplified assumptions or overly conservative estimates. You're actually getting a much more accurate picture of what's going on inside that connection. And the material we've looked at outlines a really clear 4-step process within IDEA StatiCa for tackling those retrofit RFIs.
Okay, so let's walk through those 4 steps. What's that first crucial step when you're diving into a retrofitting RFI?
So step 1 is all about understanding your starting point. It's about assessing the existing capacity of that connection. What can it actually handle before you start making any changes?
Right. So you're essentially building a digital twin of that existing connection within the software. And what's really cool is you can actually select those historical steel shapes. The sources specifically mention, those older S-shaped wide flange beams, for instance, and you can input those specific material properties that might not even be used anymore. You're truly capturing the essence of that original construction.
Exactly. You're not forcing it to fit into some modern standard. You're acknowledging the history of that structure.
Yeah.
And once you've got that digital twin built, what's the next move?
All right, so step two is where things start to get interesting. Now you're bringing in those new demands. You're applying the loads that the connection is going to have to resist after the retrofit. So based on your updated structural analysis, you input those new vertical shear forces, any axial tension or compression, and the bending moments. It's like you're fast forwarding that connection into the future and seeing how it holds up.
And this is where the software really shines, because it uses what's called a CBMM solver, which gives you a much more nuanced and realistic distribution of stress throughout the connection. It's not just a simplified average stress across the entire section.
So can you unpack that a bit more? What does that mean for the engineer who's trying to decipher these results?
Well, it means you're getting a much more granular understanding of how those forces are flowing through the connection. The CBFM solver considers things like prying action in bolted connections.
Quitting action.
Yeah, so that's the tendency of those connected elements to want to pull apart at the bolts. And it also looks at the potential for local buckling, where you might have thinner steel elements that could buckle under compression. These are things that your traditional hand calculations often miss or grossly oversimplify.
So it's a much more sophisticated analysis. You're getting a much truer picture of how that connection is behaving under those new loads. And then step three, that's where the real problem solving comes in, right?
Exactly. Step 3 is all about strategic reinforcement. So now you're going to start adding elements to strengthen that connection. And you can do this right within the software. You can add plates, welds, stiffen seats, whatever you need.
And what's really powerful is that the software instantly recalculates the stresses and checks the updated capacity every time you make a change. So you can try different things. You can compare, okay, what if I add a plate here? What if I add a stiffener there? And see which approach is going to be the most effective.
It's iterative design, but in a really streamlined way. No more tedious hand calculations or waiting for hours for a finite element analysis to run. You get immediate feedback, and that's incredibly valuable when you're under pressure to respond to that RFI quickly.
Right, and then that leads us to that crucial final step in the retrofitting process. It's all about the documentation, isn't it?
Absolutely. Step 4 is all about generating those clear, comprehensive reports that show you've done your due diligence. The software spits out a beautifully detailed report with stress maps, strain distributions, capacity utilization ratios for each component. It even checks your design against the relevant codes like Eurocode.
It's not just a bunch of numbers, though. It's presented in a way that's visually intuitive, so you can clearly communicate your engineering judgment to the client, to the building officials, to anyone who needs to understand what you've done and why you've done it.
It gives you that auditable trail that's so crucial, especially when you're dealing with retrofits. You're not just saying, trust me, it's good. You're showing them the data, the analysis, the proof.
Right. So you've walked us through those 4 steps for tackling retrofitting RFIs using IDEA StatiCa. Now let's shift gears and talk about those on-site interference RFIs. These are the ones that can really throw a wrench in the works, right?
Oh, for sure. You think you've got everything figured out in the design phase, and then bam, you get a call from the site. And suddenly there's a duct clashing with a beam or a pipe running right through where a connection needs to go.
It's the classic clash detection nightmare.
Yeah, and it's almost inevitable, isn't it? I mean, you're coordinating between so many different trades. There's bound to be some unforeseen issues that pop up during construction. And sometimes it's just human error. Someone misread a dimension or something got installed slightly out of place, and now you've got a problem to solve.
Right. And when you receive that RFI detailing that on-site interference, what are those immediate red flags that pop into your head?
The first thing I always ask myself is, okay, how has this impacted the structural integrity? Has this modification compromised the safety of the building? So I want to know, has the proposed modification weakened the connection or the member itself? Has it reduced the stiffness in a way that could lead to instability? And of course, does it still comply with the building code? Those are the critical questions that need answers, and you need them fast.
Absolutely. And luckily, the sources we've been digging into, they outline another 4-step process for addressing these on-site interference RFIs, again using IDEA StatiCa as a key tool. So let's walk through that process. What's the first step when you're confronted with an on-site interference?
Okay, so step one is all about capturing the reality of the situation. You need to accurately model that as built condition, modified geometry within the software.
So if they've drilled a hole in a web, or they've notched a flange, or they've had to shift a bracing member, you're recreating that precise modification in your digital model. You're not just approximating it or making assumptions.
Exactly. You're creating a digital snapshot of what's actually happening out in the field. And the beauty of IDEA StatiCa is that it allows you to model even those complex and irregular geometries that you might encounter in these real-world scenarios. You're not limited by the simplifications of traditional hand calculations or even some other analysis software.
Okay, so you've got your digital twin of that modified connection. What's the next step?
Step two is where you analyze the impact of that modification. You need to understand how it's affected the load paths and the deformations within the connection. And again, IDEA StatiCa shines here because it has those built-in stiffness analysis and buckling check tools.
So, for example, if they've cut out a section of a beam web near a highly stressed area, or if they've removed a bracing element that was contributing to the stability of the system, you can instantly see how that's going to impact the way loads are distributed. And you can check whether the risk of buckling has increased.
Right, and you get that feedback right away. You don't have to wait for a lengthy rerun of a full global finite element analysis to get that local understanding of what's happening. That can save you a tremendous amount of time, which is essential when you're dealing with these time-sensitive RFIs.
All right, so you've analyzed the modified geometry, you understand the impact. What's the next step in the process?
Well, step three is where you make a decision. Based on your analysis, you're either going to justify the modification or you're going to design the necessary reinforcement. So if your analysis shows that the modified connection is still structurally sound, that it still meets the required strength and serviceability criteria, then you can confidently give the green light.
But if the analysis reveals that the modification has compromised the capacity of the connection, then what?
Then you roll up your sleeves and you design the fix. And the great thing is, you can do that right within IDEA StatiCa. You can add plates, welds, stiffeners, whatever you need to bring that connection back up to snuff. And again, you get that immediate feedback on how those changes are impacting the stresses and the capacity of the connection.
So you're not jumping back and forth between different software packages. You're not doing a bunch of manual calculations. It's all happening seamlessly within that same environment.
Exactly. It's a streamlined workflow that allows you to be both efficient and thorough in your response to that RFI.
And then, of course, just like with the retrofitting RFIs, that final step is all about documentation.
Right. Step four is generating that detailed engineering report that demonstrates your due diligence. And IDEA StatiCa really excels at this. It provides those clear visualizations of strain, plate utilization ratios, weld capacity checks, bolt shear and tension performance data, all presented in a way that's easy to understand and verify.
So it's not just about finding a solution, it's about being able to back up that solution with solid data and analysis. That's peace of mind for you, for the client, and for anyone who's going to be scrutinizing your work.
It's about transparency and accountability. You're showing that you've taken the time to understand the problem, to analyze it thoroughly, and to come up with a solution that's both safe and compliant.
So as we wrap up our deep dive today, it's clear that whether we're talking about retrofitting existing steel connections or tackling those urgent on-site interferences, the key to success is having the right tools at your disposal. And the sources we've explored today really highlight the power of using software like IDEA StatiCa to make those informed decisions.
What I find really interesting is that the sources don't just focus on the technical capabilities of software, they also talk about the mindset shift that it enables. It's about moving away from those reactive conservative approaches and embracing a more proactive, data-driven methodology.
Right. And it's about recognizing that RFIs, while they can be disruptive, they also present an opportunity to showcase your expertise as a structural engineer. You're not just putting out fires, you're providing valuable insights and solutions that contribute to the overall success of the project.
Exactly. And by leveraging those tools that give you a deeper understanding of structural behavior, you can respond to those unexpected challenges with more confidence, with more speed, and with a greater degree of accuracy. And that ultimately benefits everyone involved.
So to sum it all up, we've talked about two major categories of RFIs that structural engineers often encounter. Those related to retrofitting existing steel connections and those that arise from on-site interferences. And the common thread running through both is that using software like IDEA StatiCa can really streamline the process and allow you to make those informed decisions that keep the project moving forward safely and efficiently.
And it's not just about these specific scenarios. It's about thinking about how those tools and that mindset can be applied across the board in structural engineering. Where else can we leverage that detailed analytical capability and that focus on clear, defensible documentation to elevate our work and improve our outcomes?
It's a great question to ponder, and I hope our listeners will take that with them as they continue to navigate the ever-evolving world of structural engineering. Thanks for joining us for the deep dive today. We'll see you next time.
See you next time.
Thanks for listening to Gulf Structural Insights podcast. Be sure to follow us on LinkedIn with the hashtag GSDIDEA and visit www.gsdideae to sign up and try IDEA StatiCa for yourself. Until next time, this is Gulf Structural Insights, engineering excellence in every connection and member.